So hopefully my talk will be worth you missing a bit of the lunch. Hopefully my jokes will be funny enough. So please make sure you laugh. So today I'm going to talk about JavaScript fatigue, which is the feeling you get with so many packages, with so many choices you have to make. So I've been maintaining Chai.js and Sino.js for quite a long time now. And well, I think that actually this is not a problem, and today I'll tell you why. And well, this talk comes from a blog post I've written a while ago, which got to the first place in Hacker News, and it was very controversial. But yeah, I do use the spaces instead of tabs, but this is not what I'm going to talk about today. So what I'm going to talk about today is a subject that people don't teach you in college, and please don't get me wrong, I think college is great. I just think it lacks a very important subject, which is called Realities of Industry 101. And the first truth here is that software solves business problems. So most software there, it doesn't have any great technical requirements, it doesn't need complex infrastructure, or doesn't have any rigorous performance constraints. And that's because you're not paid to write code. You're paid to solve problems, right? So actually, the less code you write, the better. And that's because technology is not a go. So using hipster programming languages is not a go. Using the latest frameworks is not a go. And I would even say that writing beautiful code and bug-free software is not a go. Because the only thing that matters is cost versus revenue. So the more you can increase your revenue and decrease your cost, the better. So we don't actually avoid writing bugs because we like correctness, right? We don't write bugs because our clients, our customers, don't like bugs. And we also don't write beautiful code just because we value beautiful code. We write beautiful code because it makes us more productive in the long run, and that's good for business. So all these things, like launching rockets, self-driving cars, robots, AI, all of that doesn't just exist because Elon Musk thinks it's very cool. It exists because people have economic interest behind it. And maybe I should not even call this section Realities of Industry 101. Maybe I should call it Realities of Capitalism 101. And well, if coding is not the most important aspect of software, well, then maybe we should start paying more attention to other aspects, such as design. So in this study Bowen has made in '75, so he studied a bunch of software, and he found out that 36% of errors came from coding, whilst 64% came from design. And the NASA Apollo project itself, 73% of all errors were design errors. And that's because without requirements or design, programming is just the art of adding bugs to an empty text file. So there's nothing worse than writing code that shouldn't have been written at all. And if you remember that cost versus revenue, it's what matters. You put even more importance in design because good design adds value faster than it adds cost. And all these things, like Vue, React, Webpack, like all these tools, Babel, they don't just exist because someone thinks it's cool to write them. They exist because they need to solve a problem. So you must understand which problem you're trying to solve before adopting a technology. Don't just adopt it because everyone's using it, just because it's cool. Because JS fatigue happens when people use tools they don't need to solve problems they don't have. And most of the times, they do that in the name of premature optimization, which, according to Donald Knuth, is the root of all evil. So why would you add unnecessary complexity to your software if you don't need that to solve a problem? Right? Our goal is to solve problems, not to write code. And if you're doing that, in the name of premature optimization, you're just adding unnecessary complexity. And the very purpose of software engineering is to control complexity, not to create it. Especially because the greatest performance of improvement of all is when a system goes from not working to working. If it doesn't work, doesn't matter how fast it doesn't work. So I think that if we approached things like we do in TDD, we would solve a lot of our problems. And when I mean TDD, when I say TDD, I don't just mean writing tests before writing code. I'm saying that we should find problems before trying to solve them. And TDD is not about tests. I even wrote about this, I think, 2 weeks ago. And TDD is about taking gradual steps towards a solution. And if we do that, we will see that we'll reduce the scope of the decisions we got to make, and therefore we'll have less options, so it becomes easier to make a choice. And this also decreases something we call analysis paralysis. And you all know what this is. This is what happens when you open Netflix and you're trying to choose what you're going to watch. Right? So you have so many options, you get overwhelmed by them, and it makes it harder to actually make a choice, because more choices mean less satisfaction. And as Barry Schwartz says in his book, The Paradox of Choice, as the number of options increase, the cost in time and effort of gathering the information needed to make a good choice also increase. And we pay for those choices with willpower. And willpower is limited. Or willpower is just like a muscle. So in this study, we can see how many favorable decisions judges give according to the time of the day. So as you can see, as the day starts, they have about 65% of favorable decisions. And then, when it starts approaching their lunch break, that number starts decreasing. But when they come back, it goes all the way back up to 65%. And the same thing happens when they're about to go for a coffee in the middle of the afternoon. So with this, we learn two things. First is that our willpower is limited. It's just like a muscle. And the second thing is that if you ever commit a crime, make sure you're the first one to go to court that day. This will greatly increase your chances of being innocent. So maybe we might not even be JavaScript fatigue. Maybe we're just decision fatigue, because we're making choices the wrong way. But well, what about JavaScript? How did we come to this place? So I think first, I should show you a bunch of impressive numbers to show how serious this is. So this is the growth of NPM in comparison to other like package repos, package management systems. And every time I give this talk, yes, that's me with the wizard hat, this number increases. Right now, we don't even have, we have more than 700,000 packages on NPM. That's an average of 592 packages a day, and that growth rate is bigger than lots of cities. The NPM registry traffic has grown 1,000 times in the last 5 years. This is huge. But how did that happen? Well, that happened because the JavaScript ecosystem has like a very... So we had many problems in the JavaScript ecosystem we needed to solve. So all these tools, as I've explained, they exist to solve problems. Transpilers, for example, like Babel, they exist to solve the problem that we have to write latest generation code and make it work in different platforms, right? We need to do things such as writing AJAX, right? So we need these things because they help us experimenting features, help us with platform compatibility and all that. Module bundlers, well, you might remember the time when we had to add multiple script tags for HTML files, and that caused lots of problems because things used to clash, to have clashes in the global namespace. It was hard to manage versions. Versions would simply not be compatible. So module bundlers exist to solve that problem, the problem we had with managing dependencies. And they also help us with lots of things like Webpack. Does a great job with bundle splitting, which solves the problem of sending less bytes down the wire. And front-end frameworks, well, you might remember JQuery. Who here remembers JQuery? Okay, painful times, but it's a great tool. So front-end frameworks help us separating how we manage, the display, how we display things and business logic. So frameworks just provide us abstractions, and abstractions that are necessary to reduce the cognitive load of how things work, so that you can focus on what matters, so that you can focus on creating. And all of that happened because the web platform moves too fast. And if we had to have standards for everything, well, we would be in a very hard place, right? Because making a standard takes time, it takes lots of drafts. You need to have multiple people give their opinion and everything. So if you actually allow the community to come up with solutions, you have natural selection. So packages that solve problems well, people start adopting, people start contributing, they get bigger, we have more material, more documentation on them. And that helps us putting the power into the hands of communities and makes it easier for us to have tools that actually solve our problems from bottom up rather than having someone tell us what should fix our problems. And also, if you take a look at the JavaScript environment, you see that lots of packages, they have kind of this Unix philosophy, they do one thing and they do it well. So for example, in JavaScript, rather than just having like JUnit, which does everything. So you have Mocha and you have Chai. So Mocha just runs tests, and Chai just does assertions. And if you want to replace one of the pieces in this stack, you can just do it, because we also write tools that work together. And also because so much complexity in software comes from trying to make one thing do two things. As I've said, we write programs that work together, so it's easier to increase the stack of technology we use. And if you stop and think a bit, you see that all these tools we have, they're not new. You know, like all of them had alternatives. Like before NPM, we had RubyGems, we had PyPy, we had many other things. You know, JSX mixing markup with JavaScript, we had E4X a long time ago. Babel, you know, compiler principles have been around since, I don't know, forever maybe. Goop, Grunt, NPM, scripts, all of that. We already had that around 64, I think, and it was called NewMake. And NewMake still solves lots of problems. Like we use NewMake in Chai, and I know lots of people that still use NewMake nowadays. And it's not because they're really hipsters, not because they want to, you know, like use these cool old tools, because it solves problems and it solves it well. React Native, well, using web technologies to develop for mobile, we already had that with Symbian WRT. I hope none of you had to use that. So how can we deal with this? Well, the first thing to realize is that, obviously, you don't need to know everything. So if you actually stop and realize that your goal is solving problems, not writing code or using cool technology, you see that you can just like learn things as you go, like learn things as they start solving your problems, and not be afraid, because every developer you know got there by solving problems they were unqualified to solve until they actually did it. And when you go learn, I think people should learn from the beginning. You'll learn computer science fundamentals on JavaScript, learn CSS before, you know, like learning like React and all that stuff. But sometimes, you know, it's kind of hard to learn how to swim by studying dynamic of fluids. Sometimes you just got to jump into the pool and try it yourself. And also, it's important to don't be too attached to a single technology and to not be defined by your stack. You know, if you're a great engineer, if you know how to solve problems, well, you'll be welcome in places that write a great variety of languages. Like, I know, for example, like Rob Pike. Like, he's very well known for Go, for example. But I'm sure, like, every company in the world would like to have Rob Pike as an engineer. And I have a tale here to illustrate this, which is called Master Fu and the Recruiter. So if you can please dim the lights, that would be very cool. Can we? I don't know if this is a yes or no, but I'll just keep going. OK, nice. So a technical recruiter, having discovered that the ways of Unix hackers were strange to him, sought an audience with Master Fu to learn more about the way. The recruiter said, I have observed that Unix hackers scowl or become annoyed when I ask them how many years of experience they have in a new programming language. Why is this so? Master Fu stood and began to pace across the office floor. The recruiter was puzzled and asked, what are you doing? I'm learning how to walk, replied Master Fu. I saw you walk through the door, the recruiter exclaimed. And you're obviously not stumbling over your own feet. Obviously, you already know how to walk. Yes, but this floor is new to me, replied Master Fu. Upon hearing this, the recruiter was enlightened. I hope you are enlightened too. So if you can turn the lights on again, that would be nice. Thank you. So another great advice is to do things that don't scale. And this applies not only to code, but also to businesses. You know, like, try hypothesis. Make sure that the code you're writing should be written. So this comes from a blog post by Paul Graham, in which he explains how Airbnb founders got there by actually like going to places themselves and taking photographs themselves, and doing all these like manual stuff to make sure that what they're doing was valuable and they were actually solving a problem. So focus on what matters, aka don't do bike shedding. And if we have time for questions yet, please ask me where the term bike shedding comes from. And I think the whole point of this whole talk is to tell people to not get ahead of themselves. Right? So apply a TDD approach, take small steps, gradual steps towards a solution, so that you can reduce the scope of your decisions and make better decisions. And well, rather than just like following tutorials or just like reading about things, try to build things, because like most of the times in tutorials, what people do is they create problems so that they can show you certain abstractions. But then like it becomes hard for you to decide when you need a certain abstraction. And abstractions, they have a cost, and you must learn that cost. So first you learn the value of abstraction, then you learn the cost of abstraction, and only then you're ready to engineer. And also something I think it's a bit wrong is calling yourselves engineers. I don't think that's a very accurate term, because you know, like some buildings have been there for a long time and they never collapse, whilst applications crash all the time, right? Software is it's a new thing. It's something we only do for like, I don't know, 70 years or something. And I have a good analogy which comes from Sam Newman's book about microservices, which refers to what we should call ourselves. So this is Barcelona, and this is Barcelona seen from the sky. So you notice a huge difference between those two pictures, right? So when you're building software, I think you should do as people that planned Barcelona did. So you cannot like predict how a city is going to look like in 100 or 200 years or 300 years, right? It just grows organically. People move from place to place, and the necessities they have change, just like the necessities you have with your software change. So rather than just like being an engineer, I think we should do more of what's like real iterative development. We should instead be town planners, especially because software is flexible and engineering is not, and our build time is compile time. We spend more time designing and thinking than building. We can break things all the time. We can always change things, and it's a lot easier to change things because like we work with pure thought. We don't work with physical matter. And we can build as many times as we want. We can test things a lot easier than people that actually do civil engineering. So be a town planner, let your software grow, adapt as needed, do proper iterative development. And well, abstractions only work well when you have the right context for them. And the right context will only develop as the system develops. Another advice I have for you is an advice I got from a friend in college, and I think it's great advice, which is to strive to be lazy. So whenever you're doing something and it feels like too much work, well then that's the time when you should like look forward to finding a better solution to your problem. But sometimes you not realize you're having too much work to do something, which is why it's so important to come to conferences like this and talk to people and see what they're doing and learn how you can improve your own workflow and be better at solving problems. But I think it all boils down to being curious. So I think this great quote from Aaron Swartz sums it up. So I think that people should be curious, read widely, try new things. Because what people call intelligence, in the end, it just boils down to curiosity. But if I had to sum this all up, I think in a single advice, it would be to solve problems. Like code is not this thing we do just because we like it. Like we offer code to the world, and we should actually make it do something for people. So focus on solving problems. Thank you very much. And here I have a few references and great blog posts, which I think will be very valuable, mostly about like how to approach requirements, how to approach design, and career in general. So I think that's it. Thank you very much. I think we have time for questions, right? Because I always speak faster when I present. Thank you. Anyone? Comments? Questions? Okay, we got one there. Nice. In how many burning projects I have been? Well, it depends on what you'd call a burning project. How would you define a burning project? So one thing, what he said is that when in a project where people focus on choosing technologies rather than solving problems. So I think one example, not of a project, but one example of what people do commonly is like when you go try to like bootstrap, like create a React application the first time, like you're not focusing on what it should do, and then you spend all this time like fine-tuning your Babel and Webpack configuration rather than just getting it to work and adding things as you need them. Like you try to predict what you're going to do, and also like one thing I see, a common misconception I see about TDD, for example, which is very related to this, is that when people think about TDD, they just think, oh, I'm going to write this like huge test, and like I'm going to write all these tests, and then I'm going to write the code, but it's not what TDD is about. So rather than just like writing loads of tests at once, like write a very simple test, make a code pass, instead of just like trying to get it all done at once, like trying to meet all the requirements at once. So I think those are 2 examples where I see that happening. And I think that also sometimes people want to use fancy tools for lots of things. Like, so there's this whole thing now about like ng making. So when people like try to build software themselves, like try to build programs themselves, and many people in the ng making community, they don't know how to code and they learn it as they go. So in their first prototype, to make sure that they need that's going to solve a problem, they start with like, I don't know, like an Excel spreadsheet, a type form, or something like that. And once they see that's needed, they then go and develop it. So I think those are some examples. Anyone else? Cool. Think of anybody here? Cool, thank you very much.